Okay, this question says vanadium, niobium, and tantalum. The names are so funky, but are metals in the same group of the periodic table. The shorthand electronic configuration of vanadium in the ground state is argon 3d3 4s2. State what is meant by ground state. Now remember, we've already studied this, that the ground state is basically the state of an atom where the electrons occupy the lowest possible energy levels, and that's the most energetically stable state, right? That's how we fill out the orbitals using the three rules that we studied: the Aufbau principle, the Pauli exclusion principle, and the Hund's rule. So what is meant by ground state? It's the state where the electrons occupy the lowest possible energy levels. Now, the next part says show the electronic configuration of vanadium using electrons in boxes notation. Now, you always know that the 4s is filled first before the 3d because the 4s is at a lower energy level. So how do you fill it out? The examiner has made sure to confuse you by showing you the 3d first and then the 4s, because we've realized that Cambridge clubs everything using the principal quantum number. So it clubs the 3s, the 3p, and the 3d together. However, we know that the 4s is filled first before the 3d. And how do we know this is the 4s and that's the 3d? Because the 3d has 5 orbitals and 4s only has 1s orbital. So how do you fill it? Well, you fill the 4s first. The electron goes here and the other electron goes here. That's 4s2. And then 3d3, we know that we first of all have to singly fill the orbitals. And that's the notation. That's literally one free mark for you. So 4s2, 3d3, right? Now it says deduce the total number of electrons in the p subshells of vanadium atom. For that, you know your beautiful periodic table approach. If I show you vanadium, it's right here. How many p electrons are there in vanadium? Well, that's the p block. So vanadium is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d3, obviously, right? Now, how many p electrons are there? 6 from 2p6 and 6 from 3p6. So it's a total of 12 electrons. That's how easy it is. 12 electrons. So that's the total number. Now it says Pelompium was the suggested name for a new element discovered in a mineral. Pelompium was later found to be a mixture of niobium and tantalum. I swear to God, these names are just tongue twisters. Only one naturally occurring isotope exists for each of NB and TA. Complete table 1.1. It's pretty easy. It's from your O-levels and IGCSE. How do you deduce the number of protons? It's the smaller number. That's 41 right here. How do you deduce the number of protons? That's 73 right here. Neutrons is the subtraction between the two. So 93 minus 41. What does that give me? Let me calculate it using my phone. So 93 minus 41. That's 52. And 181 minus 73, that's 108. And we know why we are subtracting, because 93 is the mass number. So 93 is the mass number, and mass number means the total number of protons plus neutrons in the nucleus of the atom. And you're given protons, which is 41. So you just plug in 41, 41 plus n, and then subtract 41 on both hand sides. That's why we just say subtract the two numbers. Define relative isotopic mass. Pretty easy. It's the mass of an atom, of an isotope. Mass of an atom, we literally covered it in the previous question, of an isotope relative to or compared to 1/12 of the mass of carbon-12 atom, compared to 1/12 of the mass of carbon-12 atom, obviously where carbon is exactly 12 units, where C is exactly 12 units. Yeah. And we can also write the definition as mass of an atom of an isotope compared to AMU. AMU means what? We literally covered that in the last question, but AMU means unified atomic mass unit, which basically is the mass of 1/12 of carbon-12 atom. Yeah, that's pretty much that. Easy. Moving on, the next part says a sample of Pelompium contains 90.9% by mass of Nb and 9.1% by mass of Ta. Calculate the theoretical relative atomic mass. How do you calculate the relative atomic mass? Is basically taking the weighted average. It's the weighted mean, it's the weighted average of the isotopes. And for that, you'll have to take the isotopic mass and times it by the abundance, right? And what students tend to do is they tend to take 93 and 181 like they would do in O levels and IGCSE, but realize the isotopic mass is given here correct to 2 dp. So you take 92.91 and 180.95 and then multiply it by their abundances. So NB is 92.91 multiplied by its abundance, which is 90.9, and you sum it up. It's basically frequency, right? Summation F into X divided by summation F. The abundance is the frequency and X is the isotopic mass. And then you check out this stuff right here. So TA is 180.95. So TA is 180.95 multiplied by the abundance, which is 9.1, divided by the total abundance, which is 100, because 90.9 plus 9.1 gives you 100. What does that value give me? Let's check it out. If you calculate it with your calculator, it gives me 100 and correct to 2 dp. So 2 decimal places is 100.92. That's the answer. So I write 100.92. The reason why he's calling it theoretical, because he told you the entire story above, how it was first considered to be a new element, and then they realize it's just a mixture of these two. So that's why he's calling it theoretical, because in reality this is not an element. Yes.